Hey, this is Leach with Simpson Math, and in this video, I will show you how to factor using the AC method. This is also part of a series of videos which will serve as a fundamental review of factoring geared towards the college algebra student. If you haven't watched my previous videos, especially the most recent one about factoring by grouping, stop watching this and go check that one out. But if you're ready to go, let's get started. So just a word of note for my students, if you're in my class and you're watching this, and you're ready to go about factoring trinomials, just know that for me, especially right now over your next several homework assignments, whenever I say to factor a trinomial, it needs to be under the AC method. I know you might have learned other methods, but I'm partial to this one and I think it's best. So I want you to show me that you can know this method. Later in the course, if it's just like, oh, and we need to factor, if you have some other method and after you learn this method and you try it and you show me, if you want to go back to that one, be my guest. But for the next several homework assignments and tasks, make sure that you show me this AC method. All right, so there are 6 steps when it comes to factoring trinomials. And I have them on the screen here. They're also above my head and will be there for the rest of the video. So step 1 is to rewrite the trinomial in descending order if necessary. So if for some reason it's not the right order, or you have like terms that you need to simplify and you need to combine or whatever, make sure that it's in descending order in terms of exponents. So that means that the biggest exponent is first, then the next one, on and on down to where you might not see any more. If you take a look at this, just a note about exponents. So this is a square, as you see, the first one, but then on the x is actually an exponent of 1. And then technically, there's an exponent of 0. There's an x to the 0 power on that constant, on that c term. So do you see how the exponents go from 2 down to 1 down to 0? So that's what we mean by in descending order. All right, so next, step 2 is to factor out the GCF. So check for any GCFs, anything that might be in common. But especially if you see a -1, just an extra -1, or maybe any extra x factors hanging out, factor those out. The trinomial at this point might then be inside of parentheses. That's fine. But what you should have left over is a trinomial in this order, ax squared plus bx plus c, where a, b, and c are numbers, and then you have those x's or maybe some other variable. Step 3, we then multiply a times c. So the first number, that's the leading coefficient, and then we multiply times c, which is the constant. Notice I'm not multiplying by the entire first term, that's ax squared. So I'm not multiplying the x, it's just the first number, a times c. AC is now a positive or negative integer, so find AC, multiply it together. Step 4. Find a factor pair. So previous video we talked about factors and finding those factor pairs. So that's why we covered that, because you're now going to write down your factor pairs. And you're going to find a factor pair of AC that has a sum equal to B. Be mindful of B's sign. B could be positive or negative. Next, so now that you have your factor pair in hand, you're going to stick an X on each of those and replace BX with those two x terms. Each x term has one factor pair of AC as its coefficient. So like I said, you're going to find your factor pairs of AC. They're going to add up to equal B. Stick an x on each of those, and then you're going to break apart BX with those two values. And then step 6, factor by grouping. So if you're not sure about factor by grouping, again, go check out my previous video where I covered factor by grouping, and those are the 2 steps of factor by grouping. So let's move on to our first example. So I know if you've been watching my videos, you're used to the blue boxes of you doing them on your own. Here I'm just having them be covered just so I can uncover them step by step. There will be some times that you'll do it on your own, but don't fear, you're not doing this first ones on your own. So step 1 is to make sure that they are in the right order, and they are. A little bit of a spoiler alert, all the ones on these videos, I do have them in the right order. That's just more for later on down the course. All right, next we need to look for a GCF. A little bit spoiler again, our first several we're not worrying about the GCF, but it will be showing up in these videos. So check out our GCF. If you don't have anything in common, I'm just going to say 1 because the greatest common factor of all of these is 1. I don't want you to say none because there is a greatest common factor. It's just 1. All right, step 3, multiply a times c. And just to be clear, I wrote up above this ax squared plus bx plus c, so you're again clear about how that's defined. So a, oops, erasing things, that happens. So a is that 2, c is the 4, so I'm going to multiply a times c, and I get 8. Notably, it's also a positive 8. So I'm going to 2 times 4 and I get 8. So these first several examples, I'm going to write down 2 times 4 is 8. Just so we're clear where I'm getting this number from. But eventually I'll stop writing the 2 times 4 and just be like, yeah, it's 8. So feel free to do the same, but I encourage you for these first several examples with me, write down the multiplication until you get used to where they come from. All right, so now let's find our factor pairs of 8. For no purposes, I will always be writing all of them. And again, until you become a factoring pro, I encourage you to write all of our factor pairs. As encouraged in the first video in this series, write down your factor pairs in order. So in order on my left column, I'm always going to start at 1 and then go increasing, which will make in the right column, I'll start with the value itself, in this case 8, and it will then be decreasing. Reason for this is if you ever reach, so if you're working through this, you go 1 and 8, yep, 2 and 4, then 3 and nope, and 4 and oh, I already have it. I don't have to check 5, 6, or 7. I know I'm good to go. So that's why we always want to start with these in order. And there's another reason, and I'll get to that when we get to some bigger lists. So now I have my factor pairs of AC. So the second part of 4, it says find the factor pair of AC with a sum equal to B. Now what is B? B is 9. Not worrying about the X. B is 9. So which of these could I add together to be 9? Well, that's 1 and 8. If I were to add 2 and 4, I would get 6. So if this was, instead of a 9, a 6x, then I would pick 2 and 4. But it's not. It's 9. I'm going to pick 1 and 8. So that's step 4 done. I found my factor pairs. It's 1 and 8. And just like how I write my factor pairs, the smaller ones first, over here I'm going to be using them, and I'm always going to write the one closest to 0 first for consistency reasons, and I kind of encourage you to do the same thing. And it has a slight benefit to just slightly bit easier math later on. All right, so now what I'm going to do is I'm going to replace bx with 2x terms. So this plus 9x, I'm going to split apart. I'm going to break it apart, tear it apart into 2 different x terms. And they're x terms with these coefficients. So notice I have a 1x plus 8x. So just to be clear, again, make sure we're always writing equal signs for each of our lines, because this line equals this line. So it's true that this line equals this line. So that means that is 9x equal to x plus 8x? Yes. So this is perfectly legal. What this does on the right-hand side for me, this helps me find how to break this apart. There's quite literally an infinite number of ways I could break apart 9, right? The obvious ones, I could have 3 and 6, and 2 and 7, and 4 and 5, and so forth, right? But I could also do 100 and negative 91. That would work, right? So there's literally an infinite number of ways I could break apart this 9x. What this does for me is this helps guide me for which pairs which will work. All right. So now that I've done that, at this point, notice we have 4 terms. Those 4 terms line up with my factor by grouping. So from our previous video when we talked about factor by grouping, we even saw one where I was like, don't add those. You could, but don't. So we're going to now factor by grouping. If you did add these, you would just end up back with this at step 1 and having to start over. So now let's do factor by grouping. So looking at these first 2, what do these first 2 have in common? Well, looking at the numbers, that's a 2, that's a 1, no numbers in common, but they both have an x in common, so I'll be able to factor out an x. So when I do, I'll go ahead and it'll unveil the second part as well. So I can do that and then factor out this x. So I'm going to divide the x out of each. Remember, x divided by x, that's 1, not nothing, it's 1. And x divided by x, or x squared divided by x is 2x. So we had 2x plus 1. Now, in order for factor by grouping to work, this one over here better also be a 2x plus 1. So we have this. So what's the GCF of these two? I'm not worrying about the first two anymore. So 8x plus 4. Well, the GCF of those two is a plus 4. This is an expression. These all are leading together. So whatever this sign is, if this is a plus, if this is a minus, it better be here. Okay? A lot of students, just especially if it's a plus, they don't want to write it. That is a big problem, because then you're just like making notes. We are not making notes. We are literally undistributing. So the GCF of 8x and 4 is a plus 4. And left-hand side is a 2x plus 1. Again, anytime you do your distribution, anytime you factor out, rather, a GCF, I always encourage you to do that quick mental distribution to make sure that you did it right. 4 times 2x is 8x. 4 times 1 is 4. Now, here's a note about this process. If you are able to, and if you correctly multiplied a times c, erasing things again, if you correctly multiplied a times c, and you correctly found the factor pair, then you will be able to find, you will then whenever you do the factor by grouping, you will get equal values. If for some reason you make it to this point and they're not the same, few things to check. You want to check to make sure that you didn't do any arithmetic wrong, that you didn't factor incorrectly. So check those things. Make sure your GCFs are right. Make sure that your signs are right. But then, especially if like just the sign feels off or things just are a little, almost quite not fitting, and you've double checked everything and they're all right, double check this. All right? There's a possibility that you thought you had the number pair worked, but it didn't quite. And then you kind of forced it to happen, and then you're running into a snag. All right, let's finish this up. So again, factor by grouping, both of those things match. So I can pull out a 2x plus 1, and then left inside is going to be my x plus 4. So just like from our factor by grouping, we can then pull that out. And so this just means that we just factored 2x squared plus 9x plus 4 using the AC method to get 2x plus 1 times x plus 4. So if we were to distribute this, I would end up with this right here. What's really powerful is, I'm actually going to switch to just a regular pen here. Now I showed you something similar in a previous video, but I want to show it to you with this example we just did. Now it did swap the two binomials, but let me distribute this. So if I said x times this binomial right here, I would get x times 2x plus 1, and then 4. So this 4 times this binomial, if I'm distributing, it would be plus 4 times 2x plus 1. Then I could distribute those, and I would get x times 2x is 2x squared, x times 1 is plus x, 4 times 2x is plus 8x, and 4 times 1 is plus 4. I want you to notice what I just wrote down. Do you see that this right here, I did switch the two binomials, is my answer, is my factored expression. Then notice after that, what do I have right here? It is exactly this line. What do I have right here in this third line? It is exactly what we have right here. And then again, I could add these two together, and then I would be left with 2x squared plus 9x plus 4. I hope that you see the value behind factoring by the AC method. When you factor by the AC method, it's no tricks, there's no gimmicks, there's no boxes, there's no diamonds to make, there's no just magic spell to cast, and poof, you all of a sudden end up with your factors. No, what happens when you factor by the AC method, you literally see that you are just undistributing, or just dividing. So again, if we start with our factor and distribute, we end up with our trinomial. That means if I undistribute, or factor, I end up with my set of factors. So hopefully you can see the power of the AC method in going through this method. It's fail-safe, it'll always work. Just follow these steps. Let's take a look at a few more examples. All right, for this example, I want you to try to stay about like a step ahead of me. I'm going to say the step, give you a second to do it, and then I'll unveil it. So 1's fine, it's in the right order. Step 2 is to factor out the GCF, including -1. What's our GCF? Yep, as you see, it is just a 1. All right, step 3, multiply A times C. So A times C is, hopefully you got 18, right? If you need to pause the video, you can, but so let's find our factor pairs of 18. Our factor pairs of 18 are 1 and 18, 2 and 9, and 3 and 6. Now I need to find the factor pair of 18 that when I add them together, they end up with a sum of B. In this case, my B is 11. Well, that's 2 and 9. So 2 plus 9 is 11. If you're one of my students and and I've given you a paper that's called Products and Sums, purpose for products and sums is to make sure that we get good at this idea of 1, finding the products, finding our factor pairs, and 2, of then finding this, seeing all the different ways that they add up. So make sure that you do that document. It's really helpful refresher. All right, next, now that I have that, do step 5. Replace bx with your 2x terms. All right, so we should have this. I've taken my 11x and I've split them apart into 2x plus 9x. And after you write it down, it's always helpful to be like, if I were to go backwards, would that be legal? This is true for like this entire course. If I go backwards, is that legal? Yep. So then going forwards is then also legal. All right, so now then factor by grouping. So GCF the first 2 and the second 2. You might want to pause the video and try that one on your own. All right, the GCF of the first 2 is x. When you divide an x out, you're left with just 3x plus 2, so just divide and reduce an x from each term. And then again, whatever this operation is, in this case it's a plus, write it in the next line. So we have a plus, and what does 9x and 6 have in common? A 3. And then we have, again, that 3x plus 2 left inside. Notice that I am color coding. The color coding is not required, and again, if you don't color code, you can draw underneath brackets, not parentheses. The parentheses are reserved in these steps when they're actually mathematical objects. So do not use parentheses just willy-nilly. But I'm using colors to help me out. At some point I'll stop using color, but that's a helpful tool to help you learn. All right, and then again, 3x plus 2 in both, so we can factor that out. We have a 3x plus 2 that we pull out, and the left-hand side is an x plus 3. And if you're ever needing to double check, just FOIL it back and you'll end up with that first line. All right, for our last example of this video, we're going to, instead of just factoring, we're going to find the roots of f of x equals x squared plus 11x plus 30. So if you think back to my, my roots video, in order to find a root, that means we take the function and we let the function equal 0. So we do that. So I say 0 equals x squared plus 11x plus 30. And every line underneath that will always have a 0 equals. Every single time I'll lead off with that 0 equals. All right. And then once I hit remember, once you get the factors done, then you set each factor equal to 0. So if you want to put everything together from our video so far, we should pause the video and try this one on your own. All right, let's see how you did. So it's already in order. The GCF is 1. The A times C is, well, A is 1, so A times C is just that 30. Our factor pairs of 30 are as follows. But the one I need, because I'm looking for an 11x, is 5 and 6. So then I replace 11x with 5x plus 6x. Yep, that's right. Then I do my factor by grouping. So my GCF of the first 2 is just an x. GCF of the second 2 is a plus 6. Make sure we have that sign there, the addition or the subtraction. And then we have an x plus 5 left inside. Yep, they match. So I'm able to pull out the x plus 5, and then left inside is then the x plus 6. So then, according to the zero product property, remember that, I'm able to set each factor to be equal to 0. So then I subtract 5 from each side, subtract 6 from each side, and so my solution set is x is negative 6 and is also negative 5. So there we're using factors, we're factoring these polynomials, this trinomial, in order to find the roots of this function. So I hope this helps give you a nice introduction to the AC method. In the following videos, then we'll start getting a little bit trickier. Notice all the ones in this video were all addition. Right? So I'm going to start varying the signs up a little bit. We're going to start seeing GCFs of different types. So I'm going to start then introducing you to a little bit more just kinks and different sort of kind of roadblocks and obstacles to go around, but it's all very doable. So join me in the next videos where we continue our discussion about the AC method.